Good morning, everyone. Welcome to the presentation. We're just going to give everyone about a minute or two to get logged in. Looks like the attendees are rolling in, so just bear with us and bear with it. Maybe you hear the baby in the background. That's this quarantine life now. But just give us another minute or so and we'll get started. All right, good morning, everyone. I hope everyone can hear me. My name is Greg Rath from Rath Associates, and I just want to welcome you all to our next edition of our 20-minute webinar series. The topic of this one is artificial intelligence, the next frontier for pumps. Just trying to change slides here. There we go. All right, so so this presentation is about artificial intelligence in your pumping system. So it's a very cool concept and hardly new, actually. Armstrong's been offering this for about a year or two now, and it's really a very cool concept. And I think it really goes hand in hand with New York City and the goals, the aspirations that we're trying to do, that we're trying to achieve. You know, we have Local Law 97 going on, and just a general attempt to reduce energy usage. But forgetting even that, if you're a building owner, if you are a property manager, if you're an engineer or a contractor, there's a huge benefit to having your pumps give you information on demand, pretty much consistently. So, by having this kind of information, you can virtually eliminate emergencies because your system is giving you information. It's realizing issues as they're occurring, giving you that info, and you can actually deploy trucks to solve these problems before they happen. You can stop for costly preventative maintenance calls, and on top of that, like I said, you can maximize your efficiency and combat Local Law 97 taxes. So your presenter today is going to be Tunji Asawaju of Armstrong Fluid Technology. He is the expert, the great guy. Tunji is the Global Manager for Performance Management Services at Armstrong and is responsible for specifying, coordinating, and delivering Armstrong's IoT services globally. As a Global Development and Release Manager, as well as Senior Data Scientist, his role includes managing the generation of their AFDD capabilities, delivery of their cloud service offerings, and ensuring all user interfaces bring about a high-quality user experience. So essentially, he's on the front lines of this product. He understands it very deeply, and he's going to be the perfect person to really give us insight into their product specifically, but just artificial intelligence in building services overall, I think. So as a reminder to anyone who's not been involved in these presentations in the past, the general outline is that we're going to do a 20-minute high-level overview. 20 minutes starts when Tunji jumps on. It starts in about a minute. So it's a 20-minute high-level overview. He's going to give you an understanding of the whole concept, and the whole point is to get you to think up questions. We'll have about 40 minutes of Q&A afterward, but if anyone has, wants us to get involved on a one-on-one with them and their team, we can absolutely schedule a detailed go-to meeting, another webinar, whatever you want. But again, this is supposed to be high level just to get you saying, yeah, this sounds like something for us. After the 20 minutes, we're going to break for about a minute or two. And the reason being, Wrath wants to do a little fundraise giveaway, $500. During this whole COVID pandemic, we want to do our part to help. A lot of people are struggling. A lot of people are fighting. A lot of good people. You have nurses and the frontline kind of people. So we're going to put up a little poll, and you guys can all chime in and pick your favorite. Last week, the Ronald McDonald House won, so we sent them a $500 check. This week, we've got they're on the poll again, so we'll see if they win. It was a very tight. They won by a small margin, so we'll see if they win again. Like I said, after that, we'll jump over to the Q&A. Little final slide. Next week, we're going to have Cody from Caleffi Hydronics give a presentation on the importance of proper DHW mixing. So without further ado, if you have any questions, you could send an email over to support@wrathassociates.com, or you could send or call us at 631-822-1200. There's handouts. This presentation is a handout in the webinar. So if you look at the handouts, you can find that and some other great information. And any questions that you have along the way, you have the ability to ask questions, and again, that's where we'll address them. So without further ado, Tunji, are you there?
I am. Just pulled myself off mute.
Terrific. All right. So let's take it away, Tunji.
All right. Thank you very much, Greg, for that intro. As Greg mentioned, I'll spend the next little while talking about the benefits of connecting HVAC mechanical room equipment in general at a time where cloud connectivity has really become an easy tool to use. Next slide. Okay. But first, let's talk about the maintenance problem. When it comes to maintaining mechanical room equipment, you really have three main execution strategy groups, which I would describe as 1, scheduled maintenance, 2, breakdown maintenance, and 3, predictive maintenance. So as the slide illustrates, scheduled maintenance is, as the name suggests, you arrange to have equipment maintained on a predetermined calendar, no matter its operational state. Like a car, you get the oil changed every 10,000 miles, no matter what, right? So whether it's brand new or whether it's a 20-year-old clunker, right? So this may or may not be the most efficient use of your time and money, as you can imagine. And the maintenance you execute on that schedule may not actually be curbing undetected issues yet to be encountered by that machine. Okay, so those are the challenges with scheduled maintenance. Secondly, breakdown maintenance. Simply stated, wait till it breaks and then you fix it, which is an efficient use of your time and money for sure, especially compared to scheduled maintenance. But the cost of downtime for that equipment can be unacceptable depending on the application. Like a data center or a hospital regulating humidity levels in surgical rooms, any form of downtime is just not acceptable. So that's the challenge with breakdown maintenance. Lastly, predictive maintenance. And I think we can all agree, if you knew when a problem was going to occur before that problem actually occurred, you can take immediate actions to keep that problem from occurring, right? A lot of occurs in there. And that's the power that predictive maintenance brings to the table, with clear advantages over breakdown and scheduled maintenance. Now, with all those strategies, you also have choices about how you implement them. Of course, all forms of maintenance largely involve some form of human intervention, whether scheduled or break fix for sure. Even various computerized systems can call for scheduling or break fix maintenance events to be executed at various degrees. So maybe there's forms of half human intervention, half computerized. But it's really cloud services the only strategy that currently way to detect equipment misbehaviors before they happen, right? And it uses data analytics and machine learning scripts to understand why the problem has also occurred. So that goes beyond simply detecting that there's a problem, but it's also trying to answer the question of why. And over the next few slides, we'll take a closer look at what that statement really means. The truth is, connecting equipment goes beyond maintenance. And at Armstrong, we believe connecting mechanical room equipment is the key to actively managing the performance of that machine. The visualization here illustrates how connectivity kind of completes the operation cycle. Whether we're talking about connected equipment or connected customers, both while on premise in those mechanical rooms or remotely through a laptop shown there in the upper right hand corner, to connected users at the bottom of the screen, and connected users and connected customers may or may not be the same thing, to the service dealers that help you keep your equipment running long after it's been installed. Connectivity is really the key driver keeping intelligent buildings performing at their peak efficiencies over the long run and not just 3 months after it was installed, right? In addition to predicting misbehaviors and information maintenance staff, it informs maintenance staff of those predictions, enabling preemptively corrective actions. So in general, one of the primary tenets of maintaining intelligent buildings is the ongoing activity of tracking and benchmarking performance. Simply collecting performance data is not enough, right? The collected data needs to be reviewed on an ongoing basis, and the performance needs to be actively managed in order to realize its full potential. Armstrong's active performance management program uses cloud computing technology so that we can deliver those real-time insights that enable building owners and pump owners and chilled water plant owners the information they need to take prompt actions before misbehaviors occur, like breakdown maintenance. More specifically, active performance management is really the combination of three key concepts: design envelope technology, which I'm sure many of you on this call are familiar with already, cloud services, which we're going to drill into, and something called edge computing, which we'll get into maybe in a future webinar. We'll talk about that, Greg. We'll see what that looks like. So from these three pillars, systems can learn, predict, there's that word again, and optimize their operation in real time. Let's drill into that cloud services piece, which is really the focus of this talk here today. At Armstrong, our cloud services really rest on three pillars shown here on the screen. The first one there is performance management, where we track the operational performance of the machine in question with capabilities like vibration analytics and monthly reports. We're going to take a look at that in a few slides. There's also the asset management piece, where we can manage events and changes made to that equipment, like configuration settings, firmware versions, even service repair and maintenance logs can be accessed through that capability. And then lastly, value chain integration, which facilitates even more collaborative work between us, the pump manufacturer, our channel partners and distributors like Greg and Narath Associates here, and then all of you guys, Greg's customers. The closer we can all work together, the better off those pieces of equipment are, so that they can see the long-term value and maintain their operational efficiencies years and years after they've been installed. This last one, though, is a pretty important point, so I do want to drill into it a little bit more. At Armstrong, as a global manufacturer, it's important that our cloud services really hit the pain points of all of our members of our value chain. So from our reps, like Greg and Rath and the team over here, to consultants and contractors, right? End users, people who actually own the pumps, service partners who service our pumps. Our cloud services addresses different challenges and their challenges in different ways. And you can see those on the screen. I won't read through all of them because of our time. But the takeaway here is that each stakeholder finds value that's meaningful to them. I will say, however, that Greg will be making this deck available so that you do have this as a PDF. You can keep it in your back pocket as a reference. Okay, so how do we bring all these kind of really cool high-level concepts to life? How is it practical? We do that through something called Pump Manager. And Pump Manager is our cloud asset management tool for our latest line of Gen 5 pumps, which I'm sure many of you are familiar with. And it's powered by IBM Watson Cloud Analytics Engine. That is to say that we use IBM Cloud to do a lot of our data analytics. Okay, so in a phrase, Pump Manager actually enables active performance management in intelligent design envelope pumps. At the highest level, you can describe Pump Manager as being a cloud-based performance management service with industry-leading analytics that generate pump-specific insights like deadhead and cavitation, which ultimately leads to enhanced reliability and sustained optimal performance of that equipment long after it's been installed. That's the key point there. Additionally, Pump Manager is also an asset management platform, which I mentioned earlier, where we can now manage items like commissioning reports, change management, firmware version, things that I mentioned earlier. And you know what, we can take a look at that actually in the next slide instead of just talking about it. So now that we have a little bit of more time, I see we're doing good on our 20 minutes. Instead of just talking about Pump Manager, why don't we actually log into the cloud app? So if you can pull that up, Greg, and give me, I already have access. Okay, great. So let's see, where's my mouse? Excellent. So this is the home dashboard of the Pump Manager web app. A customer who has Gen 5 pumps and they sign up for Pump Manager, this is what they would see. So let's take a look at some real pumps here. Homepage summarizes the number of pumps you have connected. This is a sales demo account, so we have some actual real pumps connected here. We're going to take a look at. Summarize the amount of savings that they have. Sometimes if this is call it an energy upgrade project, they would buy pumps to replace old constant speed pumps. They want to know how much they've saved. We can totalize that for them. Also CO2, carbon emission savings. You see the number of pumps that are connected and which category they fall into. So that's a pretty cool feature. If we go ahead and hit on the trend page and we scroll down, we can see all the pumps we have connected to this user account. This is a global account there, so they have kind of a portfolio. Go ahead and click on this guy. This guy is actively sending data to our cloud at the moment, so you can see the transmitting data. Our pumps send data to our cloud every 5 minutes, which is about right for most HVAC applications. So you can see here, they're actually overlaying each other, but you would see 5 dots. Yeah.
Tanji, hey, it's Greg. I think that, I don't know that everyone can see the screen actually. Let me make sure that everyone can see this.
Sure.
I just want to make sure. So just bear with us, everyone, because usually we just put up the PowerPoint specifically. So I just want to make sure. And Rich, maybe if you can hear me there, why don't you just shoot me a text? Let me know if you actually do see this.
Greg, it's on the screen.
Oh, you're the attendee. Okay. All right, guys, just making sure. All right, Tanji, sorry, take it away.
No worries. It's important everyone can see the screen. That's kind of the whole point of this. So what you're seeing here, if you haven't seen the screen, I'll just quickly summarize for you. We're actually looking at the web app of Pump Manager, and we've logged in as if a owner of the pumps would log in. This is what they would see. Okay, so we see the 100% speed curve there. Coming off of the sensorless map, and then you see where this pump is operating. Very good. I mentioned earlier that we do vibration analytics at Armstrong. We've actually mounted in the necessary vibration sensing equipment directly onto the pump as a standard part of our Gen 5 pump, so there's no adder price, so you don't have to mount a hockey puck sort of device after the fact. It's already there. You already have it. You bring internet to the pump, and then it starts sending the data to our cloud where all the fun analytics stuff comes up. This is where I become a little bit nerdy, but as you can see here, we get vibration in 3 dimensions, and that's pretty cool. The question is, if you don't really know what it means, then it might as well be ancient Greek to you, right? And that's where we come in, where we can help identify and track issues. What do I mean by that? Something that we've known in the mechanical engineering world for about the last 30 years is that every type of pump failure has its own unique vibration signature. And that signature doesn't just pop up overnight. It slowly builds over the months and weeks and days prior to that failure occurring. I mentioned about predictive maintenance. That's how we do it. We know what those signatures look like. There are babies. We know when they start to cry, what it means. And so once we start to see those patterns start to appear in these raw data coming through, that's how we know that maybe we think your seal is going to go in the next 60 days. That's the kind of thing, the kind of power that analytics and cloud analytics and predictive maintenance brings to the table. Something that we've already started to do is RMS. So without getting into too much detail, basically RMS is a way of tracking the root mean square of a vibration signature, taking the average value over X, Y, and Z. And then we set thresholds on that. So once that vibration value starts to go above that threshold, we can send alerts, alarms, and warnings, text messages to facility managers that say, hey, look, that pump is vibrating excessively. You might want to take a look at it. If it's beyond something that you can do, you might want to talk to one of our service providers in your area to come take a look at it for you. So that's a pretty neat feature. There's no other pump manufacturer in the marketplace today that provides this level of built-in capabilities. There are providers that you can mount hockey pucks to aftermarket and very expensive, but this is all built-in capabilities once you get your pumps connected. Okay, great. Last thing I'll show on the dashboard here is the energy savings tab, which I hinted at earlier, where we can give real-time updates as to how much money you've saved or how much CO2 carbon emissions you've reduced relative to the pump you had in there before, if you have that information. And then we can show on a monthly basis, if I scroll down, it's not paying attention, doesn't want to listen. Okay, there we go. So we can say, okay, we saved $900 last month for this pump. And then of course, when you look at your portfolio level, if you have 20, 50, 100 pumps connected, you can totalize those savings. So you can track a project, say if it was some sort of energy savings project. Okay, with that, we can maybe go back to the presentation. I do want to stay under the 20 minutes. I could do half an hour all by myself just on that. So we'll pull back up the PowerPoint. We'll let you give Greg a second there. Looks like it's still showing the browser. Oh, there you go. You're just going to reset it. Excellent. Go back into presentation mode. Thank you. So that was a quick demo of Pump Manager. A couple more things I want to touch on before we're done with the 20 minutes. Okay, two more topics: connectivity, as in how do we actually get pumps connected in a mechanical room, and cybersecurity. In fact, at Armstrong, we believe in the power of cloud connectivity so much that we've actually undertaken steps to facilitate pump connectivity in mechanical rooms across the globe that make the process of getting them connected a painless one. So as the diagram illustrates, there are two ways you can actually get a pump connected inside a mechanical room. The first way is through the IT backbone of the facility in question. So that would be the diagram on the right. Do I still have the mouse? Yeah, I still have the mouse, this guy here. Simply run an Ethernet cable to the Gen 5 pump, and its pre-configured programming will automatically start transmitting data logs to the Armstrong cloud. You don't have to do anything to the pump yourself as a building owner or a facility manager. The second way to get pumps connected is through using, if using the facility's IT capabilities is not possible, and that happens, right? If you're talking about a defense contractor or a hospital or a bank, they're probably going to tell you, no way, Jose, you're not using our internet. Fine. The pump can also push data through a separate external network that can be provided by Armstrong. We call it connectivity kits that actually can ship with the Armstrong pumps. A connectivity kit, what is it? It's really just a high-powered router and a SIM card, like the SIM cards that go on your cell phone, that we put together for you at Armstrong, and we can ship that with the pump. So you don't have to worry about end users telling you you're not getting on their network. You have a separate network, it's off of their capabilities, and so they can feel a little bit more comfortable about that. And then lastly, of course, if you have a BMS that has internet capabilities, it can go through the BMS using standard Modbus BACnet, all that kind of stuff. So your Armstrong pumps can transmit data feeds either wirelessly or through hardware, that's important, as well as go through connectivity kits or the BMS. Okay, last topic, and then I think we can open it up, Greg, for some Q&A, is cybersecurity. You can't talk about all this internet and capabilities and Facebook's tracking our information, and China and Russia are trying to hack us. So cybersecurity is super important, right? Hot button topic these days, and rightfully so. With this in mind, Armstrong has employed several approaches to keep your Armstrong devices and the data they generate cyber secure. The pump itself has a proprietary operating system, so no hackers are able to gain access through typical security gaps and found in common operating systems like Windows and Linux and iOS that doesn't have that, right? So that's good. Second thing too, the data is one way. So the data moves from the pump to the cloud. Data does not come back down from the cloud to the pump. So that is not a channel that some Chinese hacker can get into. You can't connect to the pump that way. The technical term here we use is called a data diode. Data only goes one way. And then lastly, our data and our pumps, the pump data is stored on IBM Watson secure cloud environment. So whether it's IBM or Google or Amazon, they all kind of have the same offering with the same level of leading edge cybersecurity. So we leverage all of that. And I think that's my last slide. You there, Greg?
I'm here. Yes. Thank you so much, Tony. That was really awesome. So, all right, guys, we're going to take a little quick break. So while I'm putting up this poll, do me a favor. Whoops. Do me a favor and start writing in some questions. Like I mentioned, there's the whole question tab, and we want to make sure that we address anything that's on your mind. You know, Tunji went over a lot of stuff at a high level. Here's where we want to drill in. This is where we want, you know, to really get into the detail and ask what's really on your guys' minds. You know, you guys are engineers, contractors. You guys are facilities owners, facilities management and owners. Many of you might be actually working with New York City or other townships. So, you know, you might have particular things that are on your mind. So make sure you're writing those questions. And I do see that you guys have already addressed this poll that we put up there. So like I mentioned, we do have this $500 charity giveaway as our part. We're trying to do our part during this COVID-19 pandemic. So just everyone keep voting. It looks like about 40% of you have voted. So we're going to keep it open maybe for another minute or so just to get as many people signed in or logged in as possible. And I don't know, should I, Tanji, should I tell people like who's leading right now?
You might buy their opinion if you do that. Yeah, that's right.
Exactly. It's a little different from last week. Last week it was very close. All three options were very tight. It kind of came to the wire at the end. But right now there's definitely a big leader, a definite leader. So if you have your mind set on something, plug it in.
Craig, while they're doing that, you want to take a quick question for Tunji?
Sure, yeah. Why don't you throw a quick one at him?
Okay, so a question came in. It's how does Pump Manager differ from a typical BMS or BAS? I know you connect to it, but how does it differ from it?
For sure, good question. I have a slide on that, Greg, if you want to pull back up, if it's okay, the PowerPoint.
Right.
But real quick.
Yeah, let me
Okay,
just, about 80% have done this. So I'm going to actually just close out the poll. And then I think you should still have control if you want to.
I do. I knew that question would come up. So I do have a slide on that. Why don't I just, click it here? That can help illustrate the point. If we go into presentation mode, I got to unhide the slide, don't I? 1 second. Unhide the slide. As we mentioned before, these slides will be made available to all of you guys, so you can reference that. Let's go and present that. Okay, BMS, that's a question that comes up a lot. Firstly, it goes back to the vibration story that I told earlier. So at Armstrong, the way in which we are able to do predictive maintenance is, again, when our baby cries, only we can interpret those cries, right? Like a good mother or father. So auntie and uncles don't necessarily know what the baby's trying to say, but mom and dad do. And what I mean by that is when that thing starts to vibrate and those signatures start coming through, BMS doesn't know how to do that. BMS doesn't have access to the insights as to what those vibration signatures are. Even at Armstrong, we've been connecting pumps and we have lots connected around the world, just over 1,000. We've been doing this for just under a year, like Greg mentioned. But really what the fun part of my job is we've been destroying pumps in the lab on purpose, which has been a lot of fun. And we're recording those signatures, most importantly, right? So we're pitting bearings, we're cracking seals, we're doing all that fun stuff. We're building a library of signatures, and then we're giving it to IBM Watson. So as smart as it sounds, chess playing IBM Watson, all it's doing is it's saying, okay, Armstrong factory told me look out for these signatures, and it's comparing it to the real-time data coming in off these pumps. BMS can't do that. BMS doesn't have access to that. And that's a major difference between what we do. But I would not say that Pump Manager is trying to compete with BMS. Actually, I would argue that it enhances a BMS's capability. And the way in which we do that is we can actually send the insights, because people care about insights. I know people use the word data, but nobody cares about data. I argue this all the time. They say the word data, what they mean is insights. Tell me what's happening with my pump. Don't just send me an Excel sheet of thousands of rows. I don't have time to look at that. Just tell me what's wrong. And so BMS can collect data for sure. Like I mentioned earlier, you can mount a hockey puck on a pump. You can buy those vibration sensors off Amazon. They're like 50 bucks now. They're not expensive. You can collect data till you're blue in the face. But then what? What does it mean? How do you interpret it? That's where Armstrong comes in from a cloud services perspective, because we've destroyed hundreds of pumps to get those signatures. And so we can interpret that, and through something called an API, which is shown on the screen, we can send the insights to a BMS so that a BMS can still be the user front-end visualization dashboard. So that's how the two come together. You also see here a lot of the BMSs around the world, and I mean, you guys could probably think of the top 5 companies globally. They all have cloud services. You probably knew that. And so what we do at Armstrong is we can say, hey, great, if you have a BMS that has a cloud service, then we can send our pump-specific insights to your dashboard on whatever, JCI, Honeywell, Allerton, they all have cloud services, and you can still view those insights there. The BMS can collect the data for you for sure and put it on their dashboard, but they can't interpret it for you, not at the same level that we can. And that's sort of the difference, but the synergy that exists between what we have and what a BMS would do. Long-winded answer, I know, I apologize.
Hey, Tunji, I got a question that came in for you.
Mm-hmm.
Can the system be implemented into existing systems, or does this pump also need to be included when introducing the AI function?
Yes, so the short answer is yes, it can be implemented. It's basically sort of the same answer that we just gave here. So as the diagram shows on the bottom, you install an Armstrong pump, Modbus BACnet standard, so it can connect to any building automation system, no problem, done, right? But again, it's not the data, it's the insights. So the data will travel from our pump to our cloud, be interpreted, and then from there it can go to a partner cloud or back down to a BMS or to any data system or data collection system that actually has API capabilities. APIs are kind of standard in the IT world. They come from the Silicon Valley world. It's just a secure way to send data over the internet that's cyber secure. You can kind of think of it as like a VPN tunnel that pushes data packets back and forth. So that's how that works.
Hey, Tunji, so I think maybe piggybacking off of that, so let's say someone has an existing pump. Let's give a couple scenarios.
Mm-hmm.
They have an existing pump and they want this. Maybe it's a couple years old. Maybe they have a brand new pump and they want this. And let's say they have a pump that's not Armstrong.
Mm-hmm.
So would the system be, I guess, applicable, this service, to all those various, I guess, scenarios?
Sure. You're breaking up a little bit, but I think I got the essence of your question. So if you have an existing Armstrong Gen 5 pump, you're ready to go right away. All you got to do is bring it internet, either put it on your building's Wi-Fi or run a Cat5 cable to it, or connect with Greg at Rath Associates and they see if they can't get your hands on a connectivity kit for you. You can get it connected with an Armstrong connectivity kit. So super easy. If you have a design envelope pump that's not the latest line of Armstrong Gen 5, but it's design envelope, we call that internally 3.1, which would be roughly after 2008, I think is when we started selling Gen 5 design envelope pumps. Then we do have retrofit modules that can help you become cloud connectable. So there are programs in place, and I guess, Greg, you can talk about that in a future webinar or whatever, that can help you upgrade your existing design envelope pumps to get them connected to the cloud to have all this vibration analytics and all this cool stuff that we're able to do. If you have pumps that are not design envelope, Armstrong or not, then you do want to look at maybe replacing those. In fact, if they're older than 2008, it might be time to start looking at what an energy upgrade looks like. Maybe if they are 20 years old, there are definitely solutions out there that can help you save energy, especially if they haven't been maintained like they maybe should have, like a car, right? If you haven't maintained it 20 years later, maybe it's time to take a look at replacing that car, or that pump in this case. So 20 years or older, definitely you can take a look at it. There's for sure energy savings to be had. If it's after 2008, so you have a design envelope pump, then there are programs in place for you to just upgrade them. And we're really just talking about the control module. The DEPC card goes right in, gets you connected to the cloud. You get almost all of these capabilities. Of course, you still have the older pump, not the newest line of pump with the permanent magnet and the improved hydraulics. So you don't have that, but you can get it connected. You can do the vibration analytics, which is awesome. And if you already have Gen 5, then all you need to do is just connect it. You're ready to go.
So Tunji, I think also maybe piggybacking off of that, we definitely have a lot of people on here who understand the Armstrong lingo with Gen 5 and design envelope,
Okay.
but
Right.
there's definitely people on here who don't know that lingo. So maybe you take a minute or two talking about what those really mean.
So Generation 5 is the newest line of pumps, which we launched, I think it was fall of 2017, around there. So it's only a couple years old, and it has a couple of different things. It's still design envelope, which means we have sensorless capabilities, meaning that you can know what the flow and head is of the pump based on the power and speed, which means there's no need for a flow meter in your loop because the pumps are flow meters, right? Essentially is what it boils down to, which is really, really good to know. And so that's true for all design envelope pumps, anything after 2008. But Gen 5, our latest line of pumps, has improved hydraulic and motor efficiency. So we now have permanent magnet motors, which improve the motor efficiency, where you get savings relative to the old induction motors from decades ago. So there's that piece. And then we improved the hydraulics, so there's energy savings there, and they're cloud connectable, super important piece there too, right? For all the fun stuff we just talked about. So you can do predictive maintenance and not just break, fix, and scheduled maintenance. So there's savings to be had there in your OpEx as well. So that's design envelope. In 2008, we came out with design envelope, so it had sensorless technology, but there was no such thing as IoT really, at least not at this mass scale. So there's no cloud connectivity per se, but there was improved hydraulic and motor efficiencies relative to the previous models, which was non-design envelope VIL pumps, which did have capabilities of standing them vertically in the piping versus a constant speed horizontal constant speed pump. Then you have to have vibration isolators and all that kind of stuff. So this is kind of the history and the evolution of pumping technology, I guess, over the last 25 years. But there's definitely advantages to going to design envelope vertical inline pumps versus old horizontal constant speed pumps, for sure.
Great. Yeah, and again, I guess piggybacking off of that one more time, we are planning to have a future webinar actually on all of that. So explaining what design envelope is, explaining what sensorless pumping is, Gen 5, and then even, I think someone had written here, maybe Tunji, you take a second to explain this. They've seen actually right on actually it's not on the screen right now because the poll is up, but the two motors on the common assembly. Do you want to explain that real quick?
Yeah, that's a dual in our Gen 3.1 lingo. So after 2008, we used to call those dual arms and twins. And now in our Gen 5 lingo, we call those tangos, and that's not coincidence. What you end up having is we call them, it's still one pump, but it's two rotating assemblies, and you get some benefits in doing that. First of all, you save on square footage in your mechanical room, right? It's basically two pumps in one. So you don't have to run piping and installation costs and blah, blah, for two pumps. You just got to do it for one pump. So there's savings there right off the bat. The second thing is they kind of work together, like they're doing a tango. They work in tandem. So you can now size your application for a duty standby, meaning you have the power pumping capacity of two pumps, but you only need one. So you can call that 100% capacity. One pump can service 100% of your pumping or pressure capacity. Or, which is what I would recommend, you can size them for 50-50, right? So you still have most of your pumping capacity, but now they work together. So instead of having one pump running at full speed, you have two pumps running at half the speed. You get your full pressure and flow outputs, but you're saving so much money because of affinity laws is what they're referred to. A pump running at half speed will use way less of its power versus one pump running at full speed. So two pumps at half speed use less energy than one pump at full speed. And so that's how you can do take advantage of your two rotating assemblies operating together. Hence the name Tango. They dance together to get you to where you need to go. So lots of benefits to having the 2 rotating assemblies in one.
Great, thank you. I'm going to close out this poll. Thank you everyone for responding to it. I'm going to share the results real quick from that first poll. Everyone, thank you for responding to that one. So I assume you can see it on your screens there. Looks like almost 60% of you voted on the American Lung Association, which is really actually probably the perfect charity to donate to with this COVID-19 pandemic, being that it is affecting the lungs probably more than anything. So, we will donate that $500 this week to the American Lung Association. I just wanted to show everyone that that's who we're actually sending it to, just so you're aware. But jumping back over to the questions now, there was a pump management related question. How many pumps can you connect to a single router?
Okay. I think I have a slide on that too, right? Do I still have capabilities? I do. Let's scroll down. It's actually related to the previous question about, I'm struggling here. Scroll down. There it is. Let's unhide it. Unhide. Go presentation mode. Next slide. Okay, great. It's actually related to the last question around Tangos. So with our connectivity kit, you can put up to 8 pumps on a single kit, or 4 Tangos. I think you guys understand what I'm saying. So what ends up happening is each rotating assembly, oh, we lost the screen there, or at least I did. Each rotating assembly is, okay, you're just gonna put it back, thanks. Each rotating assembly sends its own data to the cloud. And so that's okay. You can leave it in this format here. We can just make it a little bit bigger so everyone can see that. Each rotating assembly sends its own data to the cloud. They're uniquely identified on our cloud side. So it's still 8 rotating assemblies for pumps because they're Tangos, or 8 individual single rotating assembly pumps. Now we're getting into some of the lingo of pumping at Armstrong, but I think you guys get the point. It's 4 and 8, depending on whether it's a Tango or 4300.
Tanji, if I can, I have a question here also. I think it's a 2-part question or a related question. Does Pump Manager send alerts in between the 5 minutes, and then they reference on your panel, your first panel, it said that 2 items need attention. They must have noticed 2 items need attention on your home screen for the Pump Manager.
Mm-hmm. Yeah, so data, yep, you're right. Data gets sent to our cloud every 5 minutes. And on those 5-minute intervals, it triggers alerts, alarms, and warnings. So it's up to the end user to ignore them or reset them. We don't operate pumps for individuals. We would never venture to do that because we're not in the mechanical rooms, or we don't have the complete story, right? So it alerts them to that. They also send text messages. Being on the cloud, that's actually one of the cool features of being on the cloud. It can send text messages to your phone. Hey, your pump's excessively vibrating. You might want to take a look at it. So that's the answer to that. It does not become more granular than that, but the alert, alarm, or warning will stay active until the next 5-minute interval. And if it's still an active alert, then it stays active, right? So it doesn't reset itself. So I think the answer you're looking for is it doesn't keep sending you messages in between the 5-minute intervals. In fact, as long as that condition stays open, it just sends it, and it doesn't keep pinging you every 5 minutes, because you can envision how that can become pretty annoying, right? Especially if something's you're at home and something's wrong and it's an hour before you can get there. You don't want to keep being texted and emailed. So yeah. I thought you said it was a 2-part question. Is there a second part that I missed?
Yeah, I think what he's saying is that also, if you had in between the 5 minutes, if you went into a deadhead condition, would you be able to send an alert for emergency applications or emergency conditions on the pump?
Yeah. So the short answer is yes. So the alert will be sent at the state of the condition is detected. And then actually on Pump Manager, you can actually snooze alerts and alarm and warnings. So you're like, yeah, I know it's deadheading. I will be there in an hour. You don't have to keep messaging me every hour or whatever the interval is that you want to be detected. So you can actually kind of turn them off temporarily, and then you can reset them just like you would with the BMS, I suppose. So yeah, the short answer is yes.
Hey, Tunji, I think a really great feature of this, I mean, it's funny, I always joke around, the amount of money you guys have probably put into this program, but one of the things that I think excites people more than anything is the fact that now we can know remotely when a pump has been put in hand mode. You want to just maybe talk about that?
Mm-hmm. One of the things that come up the most, and one of the alerts that I see the most with all the pumps we have connected around the world, is pump in hand, and largely it's not pernicious thing. What I mean by that is it's not people are trying to screw the pumps up. Of course, leave it in auto, let it do its thing, especially if it's being run by a BMS or something like that. But every once in a while, you want to lock it in hand because maybe you're changing out a valve that's downstream of the pump, or you're doing some sort of other maintenance in the system. You want to lock it in hand or turn it off. You go and fix whatever leaking pipe downstream, and then you just forget. People just honestly just forget that they left the pump in hand, and so they go home. Right, and then that thing could be left in hand. I've seen pumps left in hand for prior to Pump Manager for months. They just completely forgot, locked it in at 70% speed, right? Instead of letting BMS or the pump itself ramp itself up and down based on demand for flow. And so knowing that a pump is in hand is like, oh, you know what? I forgot I left it in hand. Good thing I had this text message to remind me, because it's just like that easy. And leaving a pump locked in hand, which may still deliver the flow and head that your air handlers or your boilers need, but you're not being energy efficient, right? And in fact, you're wasting energy potentially. If that pump doesn't need to be running at 75, it could be running at 60% of its speed to meet demand. So it's good to be able to be on top of those things for energy conscious, performance management conscious building owners and facility managers.
Yeah, like I said, everyone that we've spoken to so far has jumped out of their socks when they heard about that, and then they laugh, kind of look at each other saying like, oh man, like this happens all the time. Anytime I go in a mechanical room, we always see our pumps in hand mode, and all we keep thinking about is all the energy that we're not saving and all the money that we're not saving. We have these expensive variable speed pumps, and they're not able to do their job, and it's just a nightmare. And then on top of it, right now with Local Law 97, where there's this whole mobilization towards electrification of New York and clean energy, there's a push towards just obviously operating more efficiently. And with Local Law 97, there's high taxes on your carbon emissions. So if you're actually not dialing down your energy usage as you should, then you're paying for that utility right there, the utility bill, but then you're going to get double banged because you're going to get taxed on it. So it's just a major thing that I think is people really get excited about. It might almost be worth the cost of admission itself. So I think there's a couple other questions that have popped up.
Sure.
And guys, for anyone who may not be familiar, so we're addressing the questions as they come in. But there is the option to throw a question at us. So there's a little button on your screens where you can do that. So jump into the next question is, considering the Tango, so are we to understand that the Tango has two separate vibration modules, or is it referred to as Tango A and B?
Two separate vibration modules is the answer. So like I said, each rotating assembly, so those are the two motors essentially, and one pump casing. Each rotating assembly is tracked individually. And then on the cloud side, we can, with Tangos, what we do is we actually do a combo analysis, right? So it's actually really interesting. I can share a bit of insight. What we've seen over the last year and a bit with this service is you would think that the pumps with two rotating assemblies actually vibrate more than a single pump, right? That's kind of what I thought going into it. What we found was that the two rotating assemblies vibration behavior were canceling each other out, which when you think about it, actually makes sense. And so the magnitudes of the vibrations that we were receiving from tangos was less than the vibration magnitudes we were seeing from 4300s, which threw me off at first. And then when we dug into it, we're like, oh yeah, that actually kind of makes sense. So some really, I'm nerding out here a little bit, but some really interesting stuff that we started to learn just in the early days, and then interpreting what those vibration signatures mean. So two, they're separate, to answer the question.
Tanji, I see another question here. With regards to this pump manager, are you looking to also have, or do you have it now? Are you looking to also get into other pumps, example like booster pumps?
Great question. Funny you asked about boosters. We will, the next line of boosters that Armstrong will be making available later this year will have cloud connectivity. In fact, what I can tell you is Armstrong, I personally have a mandate to make all Armstrong products cloud connectable over the next 18 months. So as you can tell, I'm going to be a pretty busy guy. And so boosters, circs, even heat exchangers, which Armstrong sells, every one of our products, I have a mandate to make them all cloud connectable and generate insights for this kind of thing. So boosters specifically is on the roadmap for later this year with the latest line of we're calling it Gen 2 boosters for those who know the Armstrong lingo. And they will have the permanent magnet solution sitting on top. So all that kind of stuff is really, really cool and exciting product line coming up. All of them will have connectable features in the future. And what another thing my team is working on with all of our different internal product managers is how do we get stuff that's already sitting in the been installed for years and years and years to get them connected. So retrofit packages to get them connected as well. So that's also good news. If you happen to have bought an Armstrong booster 8 years ago, we're looking at ways you can get that guy connected as well.
If nobody else has got one, I see another one here, Tunji. If you have a problem with a pump and you get sent an alert, will it also provide the part numbers that you're going to need for the condition registered on the pump manager?
That's exactly the whole point of cloud services. Great question. I really like that question. So it means that they understand where this is going. So once we understand what the problem is, then we can start to offer up solutions, right? So if we know, hey, we're predicting that seal is going to go in the next 60 days. Okay, maybe it goes in 75 days, right? It's a statistics game, so to speak. But the idea is you knew that it might come up. You can actually take steps, and then we say, okay, here's your pump model. We have the pump serial number. Here is the part number you need for that seal that you need to buy for that specific pump model number and serial number. So here it is. You can go ahead and buy that now or just have it on your shelf so that when that seal does go, like we expect to go, you'll be able to switch it out right away. If you can't, you don't know how to change a seal, here are the names of some of the Armstrong preferred service dealers in your area that can come and do that for you. That's like an easy example, right? So the short answer is yes. That's the kind of thing that the cloud services aims to do.
I got another question here. So, what's the question here? Can you have different levels of access? So if you have a facility, let's say a campus, is there a way to have one person see only their building that they're in charge of, and then have different levels of access? Or if you own maybe, 30 buildings, different people have different levels.
Short answer, yes, of course. So if you imagine yourself as a facility manager or a portfolio manager, like I'm just going to Oxford Properties or something like this, right? They got tons of buildings all around the world, right? Let's just zero in on maybe New York City. And so if they have Armstrong pumps in all these buildings, what we would say is that's not really just a building to building account. That's an enterprise level account. So someone who's sitting at the Oxford Properties head office on the maintenance side or on the operation side can see all the pumps that they have connected across all 50 buildings across the city. And then what they can do is they probably have managers for each building or each like 5 buildings apiece, they can give them access to only see the buildings that they're managing, while they will be able to see the higher level portfolio access. And the great thing about having these different levels of access, especially on that summary dashboard, you can see what the totalized or aggregate savings of CO2 and carbon emissions are for your entire portfolio, while people with lower level access can see the totalizations of savings for just their pumps or a specific pump. So the short answer is yes to all of that. And then, sorry, I'll just add one more thing. So that person with the highest level access, we call them success managers. Really, that's just a customer administrator. They can manage the user accounts for everybody who is of a lower level access. Just that's a key point I didn't want to leave out.
I have one more here, Tanji.
Yeah, shoot.
On your system, this pump manager, let me see, it says it monitors the Armstrong pumps. Are you planning to maybe bring in and deploy sensors to monitor other aspects of a system, like a chiller lines, temperatures, flows, and other data?
We actually do have another service offering called EcoPulse, which is for chilled water plants and boiler plant applications. And that's another active performance management service. This call was specifically around Pump Manager specifically. Pump Manager rolls up into that. So the short answer is yes, we do have offerings for that, which tackles water side, I would describe as water side HVAC equipment. So that doesn't, see, the thing is, we're not trying to compete with BMS, right? That's not the goal here. The goal here is to do deep dive analytics into water side equipment, starting with the pump. We also have EcoPulse, which looks at boiler and chiller plants. So that means chillers, cooling towers, boilers, if there's a boiler, heat exchangers, all the kind of stuff that would be on the water side of a building. And then we feed that information into a BMS to make it smarter, enhance their capabilities and their value to the end user. So we're not looking to compete with the Honeywells and JCIs and the Allertons of the world. We're looking to actually be collaborative so that we can all work together to do our part for our planet proposition and save energy and all that fun stuff. So the short answer is yes, we do have services for that as well. If you have more questions around that, you can certainly contact Greg and the team at Rath, and we can do a one-on-one and do a deep dive into some of those offerings.
That's a great point. Yeah. So I guess as a reminder, keep the questions rolling in. You know, we'll hang on here probably another 5 minutes or so if the questions keep rolling in. But yeah. So as a reminder, because we still have almost most of you on this webinar. So thanks for sticking through and keep sending the questions in. So as a reminder, anyone who wants to get together and do a one-on-one, it could be a phone call, it could be a webinar, it could be a go-to meeting. We can meet in a field somewhere and stay 10 feet apart, whatever you want to do. And we can dive deeper into this product, into anything in the Armstrong line, anything that you want. So, please be sure to reach out to us. A little reminder, the email, it's very simple. It's support@rathassociates.com. That's SUPPORT @rathassociates.com. So I'll just make sure to put that back up, unless Tunji has to.
No, go ahead.
I do have one more question here, or comment. The question is, with your system, it looks like it's going to be able to actually save energy. Have you worked with NYSERDA or other city agencies to get any kind of credits or initiatives or incentives for your product?
Yeah, the short answer is yes. At a national level, the short answer is yes, mostly with the utilities. So the utilities love stuff like this, right? In fact, some utility jurisdictions actually will help finance pump replacements with the kind of savings that we're able to claim during the sales process, but more importantly, validate after it's installed with stuff like Pump Manager, right? So we're not just claiming it and saying buy it and then off you go. Hey, you actually saved 110% of what we said you would, or 80%. And if it's 80% or 50%, then the question is, why are we short? And that's when it comes to stuff like, well, you left the pumps in hand for 36 days. So why do you think you're short, right? It's sometimes it's really basic level stuff. It's not high analytics and statistics and vibration. Sometimes it's really just you left the pump in hand and you locked it in, and that's why you lost all these savings. Well, let's not do that. And so the short answer is yes. We have worked with utilities for sure. A lot of city level stuff depends on your jurisdiction. If there are programs that are out there and you're aware of them, certainly, I'm sure Greg can speak this better than I can for New York City specifically. That is the kind of thing that us as a manufacturer with our partners like Rath Associates can help facilitate those types of initiatives. But the short answer is yes, we have done that in the past.
Okay, another question, the follow-up to that, I guess they're saying is that if our people in-house are not responding to what you will see as an energy wasting operating mode, can you have the ability to notify either the local rep or somebody to let us know internally as a one-to-one to our facilities manager?
Yeah, so my answer to that would be, it's actually a long answer. The law states that the person who owns the pump owns the data that pump generates. Okay, so that's a key piece of information. So what that means is, in practical terms, is that yes, you're sending the data to the Armstrong cloud for interpretation, but it is the owner's data. It's not Armstrong's data. We don't own it. Our position is we are the custodians of the data. We take care of it. We make sure it's safe, but we don't own it. At any time, the owner can say, give me my data and I want to delete it off your servers. No problem. That's the law. That's the way it goes, right? The interpretation of the data, though, is we use our IP, and we've destroyed lots of pumps. So my executives want me to pay that back, sure. But the interpretation of that data is the Armstrong IP, and then we make it available to you so that you can operate your pumps effectively. Okay, so why do I start with that? Because who you want to see the data is up to the owner. So if the owner says, hey, look, I want the person who sold me this pump, or I have a service maintenance guy who's capable of maintaining Armstrong pumps and my York chillers and my Evaco towers, whatever. I want them to have access to this. It's your data. It's your platform. It's your pump manager. You can give access to whoever you want. Just add them. You can add new users. It's super easy. So the short answer is yes. The person who sold them that pump could see those alerts, alarms, and warnings and the savings, but that's up to the owner, and they have to give them access. It's not for
I got to thank you on that comment. I got to thank you on that response. Thank you, Tunji.
No worries. Okay.
Hey, Tunji, here's another question. Do you guys have any data on estimated savings that someone might get from using predictive maintenance, from I guess from your platform? Is there any data that you've compiled?
Loaded question. It really depends on the application. So if the application is something like for a data center, which is big servers, lots of water, cold water being provided, and so on and so forth, a predictive maintenance piece could mean hundreds of thousands of dollars a day, right? Or a hospital who does surgeries every day. And so you have to keep the humidity levels up. So you can't have those pumps or those chillers go down at all. So what's the cost of having your HVAC go down? You can't do surgeries. So what's the cost of that? Could be hundreds of thousands of dollars depending on the surgery. Versus like a Walmart, who maybe they're a little bit warm in the middle of the summer. What's the cost of a pump going down? Well, okay, they're a little bit warm, but the store's still going to stay open. So it really depends on the application. Could be hundreds of thousands of dollars a month, could be $50 a month, depends. It depends on the criticality of your cost of not predicting a failure, if that makes sense. Does that make sense? I hope that answers the question.
It does. And maybe it's not possible to answer. Would you be able to boil it down at all to like a percentage, or is it still just too difficult with the various applications?
Depends on the application, but what I can say is anywhere from 2% to 90%. Like it depends on the application, right? I mean, I don't want to say 50%, and then for a hospital it's way more, and for a Walmart it's way less. It really depends on the application.
Any special any special applications for data centers?
Yeah, I wouldn't say it's a special application. I would say that Pump Manager and what predictive maintenance and cloud services brings to data centers is so much more critical. They just, like I said earlier, downtime is just not an option for them. They cannot be down, full stop, right? So it's a risk management tool, if you want to think of it in those terms, that they're protecting themselves against the risk of operations going down. versus, again, I use the Walmart because we all understand it, versus the Walmart, okay, fine, the pump goes down, customers are still going to come in the front door, they're just going to be uncomfortable. So it's a kind of a risk management tool when you think about it. High risk for data centers, so
all right, guys.
high value.
It's 11 o'clock, and a lot of people are still on, but I'm thinking we should probably start to maybe dial out of this thing. So Tunji, is there anything that you want to leave off? I guess some final remarks.
No, I think that's great. Hey, anyone has any further follow-up questions, connect with Greg and the team there, and he can connect with me, and we can do one-on-ones, or if it's just something that's simple email, Greg, you can obviously forward that on to me. I'm still available to answer questions, and Greg, you have my number, obviously, so we can help get back to them.
Terrific. All right. Thanks again, Tunji. Thank you, everyone, for joining us. We're going to be sending out certificates. We'll be sending out the donation. Thank you all for taking part in that, and everyone who asked to be contacted. We look forward to speaking to you very soon. So that's it. Thank you, everybody. Have a great day.
Thank you.